Hello everyone, welcome back. Today you will learn about protons, neutrons, and electrons and review a little bit about isotopes we covered last class. And so these three items. So last time we learned that isotopes are same element, different mass, right? Different mass. And how do we get those different mass? Change the number of neutrons. Different number of neutrons. Okay, change or different number of neutrons. We can't change the number of protons because that changes the identity of the element. Protons tell us the atomic number, which is the element. If we change the proton, we change the element. If we change electron, it doesn't affect the mass because electrons are so very, very, very tiny and very, very light in weight or in mass, so they are negligible. Okay, so you should have in front of you a handy dandy periodic table like this. We're going to go ahead and label some things on here. Okay, so on your periodic table, nicely and neatly, what you're going to label, follow along with me and label that. Okay, so we have what we call columns. These are columns are going up and down, so columns go up and down, so they go vertical like this. There are 18 of them, and they are called families. Families or groups. There are 18 of them, and these are the numbers on top of your periodic table right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 families or groups. Okay, and going down, we have what we call periods. So over here we have your periods are rows. 1, 2, 3, 4, 5, 6, 7. 7 rows. Notice these two rows at the bottom here, they're connected to row 6 and row 7. They're continuation. Okay, it's placed down here because it would stretch the periodic table out, and so really putting it down here just to make it look nicer and fit on one sheet. The periodic table should extend all the way out very long if we put these in the middle right there. Okay, and these are not very commonly used. Some of them are, like uranium, and really that's the only one I can think of that's very commonly used down there. But that's the periodic table. 18 columns, 18 families or groups, and 7 periods. And so you will learn a little bit about the periodic table today. You use it to find your protons, neutrons, electrons, and this concept called valence electrons. Valence electrons. These are electrons on the outermost shell. Let me use a different color here so we can distinguish. On the outermost shell, electrons on the outermost shell, they are responsible for bonding. On your paper, write neater, write it's a little better than me, okay? Because right here, I'm just going without any kind of prior planning. So for you, you see it, write nicer and neater on your paper. So valence electrons are the outermost electrons on the outermost shell, responsible for bonding. And so how do we figure out the valence electrons? Okay, we're only going to talk about main group element. Main group elements are these here in the first two columns, as well as over here on this side. These are your what we call the main group element or representative element. Representative or main group. Okay, main group or representative elements are these two groups. All right, you can mark up your periodic table as many times, however you want. If you need more periodic table, just come to me. I'll give you more. Okay, so that's perfectly fine. Mark it up. Have different things on there. Whatever helps you. All right. So the valence electrons, if you see here, 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. That tells you the number of valence electrons. That's electrons on the outermost shell. Okay. So 1A would be one valence electron in this whole group. 2A, 2 valence electron. Everybody in this column, everybody in this family has 2 valence electron. Beryllium has 2. Magnesium has 2. Calcium has 2. All right. And over here, boron, we skip over transition metal, which we will talk about when we get to the periodic table unit. Transition metals, they have valence electrons, but they're all shared and they behave differently. So there's not a specific number for transition metals. Okay. And group 14, the carbon group here, is 4 valence electrons. So 3 valence here, 5 valence, and so on, 5A, 6A, 7A. Group 18 here is a little more special because they are noble gas. They are 8 valence electrons. They all want to be 8, what we call an octet. A full octet is a full shell. These are your noble gases. They're full. They all have 8 valence electrons, 8 valence electrons, 8 valence electrons, 8 valence electrons. Except for helium. Helium is the exception because helium only has 2 electrons. Helium only has 2 valence electrons, so then helium has only 2 valence electrons because it only has 2. And if you remember from the Bohr model from 8th grade, right, you draw the Bohr model, the nucleus in the middle. The first shell has 2 electrons, the second shell has 8 electrons, the third shell has 8 electrons, etc., and so on and so forth. So that's what that means. The first shell, it only takes 2 to be full, and helium has 2 valence electrons. Okay? And so, with that said, you have this worksheet in front of you. This worksheet here. I'm going to use a used worksheet because I don't want to waste another sheet here. So you look at, find the element carbon, for example. This has atomic number, which is the number on top. So bitty number on top there. Carbon has 6 valence, the atomic number 6. We put in for 6. Atomic number, remember, atomic number is equal to proton is equal to electrons. When it's neutral, okay? Neutral meaning it does not have a charge. It has an overall 0 charge. When positive equals negative, it is neutral. It cancels each other out. For example, 6 protons and 6 electrons, they cancel each other out. So the overall charge is 0. And the group number, you look at group is on top. Remember, the group is on top, 14. Valence electrons, it is 4. All right. Cation and anion, here I wrote here, cation is positive. Does it make a positive? Cation is positive. So you see a plus sign in the middle of that word, there's your positive sign. Anion is negative. I don't know how we think about it. There's more N's, so there's more negative. I don't know. However you guys think to help you remember that. Cation, there's a plus sign. Cat, or, I remember this back in the past. Cats has what? Cats has paw, so they're positive. Okay, get it? Cat, paw, positive. Right? It's not my joke. I just got it from somewhere else. So if it's not funny, give me credit for it. If it's not, it's somebody else's joke. So, all right. So cation are positive. So this is where you have to figure out: is it going to gain electrons or lose electrons? Okay. So the idea here is to get 8 electrons to be full, or lose to 0 on that, so 0 on that level to get 8 underneath. What I mean is, if there's 2 electrons here, there's 8 electrons here, there's 2 electrons there on the third shell. So right, first shell, second shell, third shell. So if we lose, there's 2 options here. If we have 2, we can gain 6 or lose those 2. Atoms are lazy. They want, the more they lose or the more they gain, the more energy required. Just like us. We want to take the easiest way out. So atoms will do whichever is easier. Is it easier to gain 6 or lose 2? So if it loses 2, look here, if it loses 2, guess what? What's underneath? A full shell is underneath. It always wants to be a full shell. So if it loses 2 electrons, so now you have, let's say, for example, find one here that loses 2 electrons. Calcium. Calcium has 2 valence electrons, right? It's going to lose those 2. So let's go down to calcium here. Let's fill out the valence electron is 2, just for their sake of here. So it can lose 2 or gain 6. It's going to lose 2, so then calcium is going to have a 2 plus charge. So you write as calcium 2 plus. Because now, calcium's element number 20. Look here, calcium's element number 20. Right? It has 20 protons and 20 electrons. If we lose 2 electrons, now we have 18 electrons. So now we have 2 more protons. That's why it has a 2 plus charge. All right? Pretty simple math. Maybe you've learned it in the past, maybe you haven't. So just take a moment to absorb that, to take that in. Okay? So 20 protons and 18 electrons now. It has a full shell underneath. Therefore, it's going to be positive. It's got 2 more protons, so it's positive. Let's look at one that's going to be negative. Negative, negative. Iodine. Let's look at iodine. It has 7 valence electrons, right? Because it is in group 17. Another way to get valence electron is, look, whatever group they're in, just drop the 1 in the front. Just take the just drop the tens place and use the ones place. So 13, drop the 1, 3. 14, drop the 1, 4. 17 for iodine, so you have 7 valence electrons. And so if 7, you can lose 7 or gain 1. Which one is easier? Yeah, it's a lot easier to gain 1. So if it gains 1, iodine gains 1, it's going to be negative 1 because now it has 53 protons, and it gained 1 electron, so now it has 54 electrons. This is for iodine, okay? So if it has 1 more electron, then you write it as iodine minus 1. And when you write a minus for 1, you don't put the number. Okay, for 2 or above, you put the number. Okay, so for oxygen, we'll try one more. Look at oxygen here. What group is that oxygen in? It's right there. So oxygen is in group 16. Drop the tens place, you have 6 valence electrons. 6 valence electrons. So now, are you going to gain 2 to make 8? Remember, the goal is to make 8, right? The goal is to get to 8. 8 is the magical number for atoms, except for helium and hydrogen, but we'll talk about that later. So the goal is to make 8 here. If you have 6, is it easier to gain 2 or to lose all 6? Which way is closer? So it's going to gain 2 electrons, right? So then your oxygen is going to be 2 negative. Remember, electrons are negative, so then therefore, if you gain electrons, you become more negative. If you lose electrons, you become more positive. Okay, it's kind of reverse thinking. And you know that in math. Anytime you deal with negative numbers, it gets a little opposite of what we think, right? So, as opposed to that, so go ahead and fill out this table. Atomic number, protons. It doesn't ask about mass here, but remember last time we learned about mass. Mass is really proton plus neutrons, and this table is not focusing on that. Okay. So if you look down here, ion, chlorine. The number of proton is atomic number. Find the atomic number. Chlorine is element number 17, right here. Element number 17, right? So you write it's 17 protons. Just get in the habit of putting P plus as well. Didn't ask for it, but let's get in the habit of doing that. 17 protons. How many electrons? It should have 17 as well if it's neutral, but look, it's negative 1. They didn't write it right. See, they're not supposed to put the 1 there. They're supposed to just put the negative sign. But it helps. So negative 1. How did it become negative 1? Did it gain electrons? So negative means it gained electrons. Okay. Positive means it lost electrons. So here it gained 1 electron, so now you have 18 electrons. All right. So strontium, go to this next one, SR. SR is all the way over here in number 38. It has 38 electrons. So it's positive, therefore it lost 2 electrons, right? Positive 2, it lost 2, so now you only have 36 electrons. Okay? So my video limit is coming to an end. I have another minute here to talk about over here protons and electrons. The ion here, I have 1 minute to talk about this. So protons, it tells you find this element. So this is atomic number. So proton 56, let's say, go 56, 56, 56. That is element barium, Ba, on column number 2. So you're right, barium, Ba. So it lost 2 electrons. So here, clearly here, we see it lost 2 electrons to get to 54. So if it lost electrons, what is it? It's going to be positive 2. So positive 2. So you write 2 plus. Write the number first and the sign after. Okay. Hopefully that helps. We have I have 30 seconds. Let's do one more right here. Element number 50. Look at element number 50. Yeah, that's SN 10. SN 10. It lost electrons as well. Again, 50 to 46. It lost electrons. So how many did it lose? It lost 4 electrons. So then we have 4 plus 10, 4 plus on that one. Is there anyone that gained electrons? Yeah, this one gained electrons. 86 one gained. All right. Finish this paper, and we'll go on to the next one.